To continue the lesson for solving the systems today, okay? The geometry class will find this very, 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 very familiar because we've been working on the same thing in geometry. If you have a system of equations, three things can be possible to happen, okay? One thing that might happen is the lines might be intersecting. That's what we were working on yesterday, when you had two lines that intersected. You graphed them, they intersected, and the one point where they intersected was the solution. So that's the first thing that can happen. When it has the one solution, there's a special couple of terms that go with that. It's called consistent and independent. Consistent means that there's at least one solution. Independent means that one line is doing its own thing, the other line is doing its own thing. The only thing they have in common is that one point that's the solution. So this particular scenario where they're intersecting would be called consistent and independent. They may also possibly be parallel. What does parallel mean? I know you remember that. Yes. Side by side, do they ever cross? No. So non-intersecting. And when you've got two parallel lines, if you tried solving that by graphing, they would never intersect, so there would be no solution. When there is no solution, we have a special word for that. It's called inconsistent. So if it's parallel, we have no solution. It's called inconsistent. Now, one of the things that we're going to talk about today is to figure out, without actually graphing it, whether a system is going to be inconsistent or independent, or, let's see, if we have independent, that means that there's probably somewhere a, what type? If there's independent, there's probably a dependent somewhere. Dependent is what we call coincident lines. Okay, coincident might be a new term for you, but coincident means that when you solve it, you find that you put it in y equals mx plus b form, it's really the same line. They may look different to start, but you find out that it's really the same line. And you say, oh, what a coincidence, it's the same line. Not really, but that's how I remember that it's coincident. They're the same line. You solve for y and find out that y equals mx plus b is the same for both. That means there's infinite solutions because they're really the same line. You wouldn't say they're all the same. It's not all numbers are solutions because it's just the ones along that line, but there are an infinite number of them. And what we call that is consistent. Consistent means that there's at least one solution. Well, sure there is. They're infinite. And it's dependent because one definitely depends on the other if they're the same line. And when we're looking at these, though, when we put them in y equals mx plus b form, we're going to be able to tell without graphing them whether they're independent, inconsistent, or dependent, because we're going to think about the slopes. Let's think about parallel first, because we've talked about that a lot. What's true about the slopes and parallel lines? They're the same slope. Would the y-intercepts be the same for parallel lines? They actually can't be. Because if they were the same y-intercept and they had the same slope, they would be the same line. So that would make them what? Coincident. So parallel have the same slope, different y-intercepts. Coincidents have the same y-intercept and the same slope.
Are you recording?
I am. And the intersecting ones have one solution, independent. What about their slopes? Well, they could be perpendicular and also intersect. So they could be negative reciprocals. Really, the only thing that we have to see, the only criteria is that they have to be different slopes. Okay, they might be negative reciprocals, maybe not, that doesn't matter. But intersecting will have different slopes. Parallel will have the same slope, different y-intercept. And coincident will have the same slope, and the same y-intercept, because they're really just the same line in disguise. And in a minute, we're going to go through a whole bunch for practice. Now, this is a typical type of question that you'll have to answer regarding those things. You have to determine whether each state system is inconsistent, dependent, or independent without graphing. So in order to do that, what do you suppose we're going to have to do with the pair of equations? Beautiful. We're going to put them into y equals mx plus b form, slope-intercept form. So you'll have to solve this one for y, solve this one for y, compare their slopes. Now, if the slopes turn out to be equal, which one of these is it? Which one of this, dependent, independent, or inconsistent? If they are same slope. Inconsistent. If we find out that they're different slopes, which one is it? Which out of these? Independent, different slopes. How about we find out they're the same slope and they have the same y-intercept? Dependent. All right, so what I would like you guys to do is I would like you to work on these problems. I will help you. We'll take a look at the answers shortly. Okay, when you take a look at the first one, you guys should be about done the first one by now. What we notice is that our slope here is negative 3/2. It's different than this slope, which is 5/3. They may or may not be negative reciprocals. These don't happen to be. As long as they're different, we have independent. So that's our first one. Go ahead and work on the second one. All right, just taking a look at the second one. When you solve it, we find out that both of them have negative 1/2 for their slope. They have different y-intercepts. That makes them parallel lines. If you were to graph them, you'd start at the 7 here, go down 1 over 2. If you started 9 here, down 1 over 2, you'd find two parallel lines. Inconsistent. Same slope, different y-intercepts, inconsistent. A second. All right, the third one. When you solve it, you find out you've got the same slope. You've also got the same y-intercept. They're the same line. They're just written in different ways. You solve them, we find they're the same line. That makes them dependent. They're not even intersecting. Coincident. They're the same line. What a coincidence. Yep. So dependent, it's the same line when you solve them out. And that would be that one. Let's work on the last one. Yeah. All right, last one. We'll take a look at this. We solve it. We find out the slopes are completely different. They have a 3, but one's 3/5 and one's regular 3. Independent. Okay, independent. Different slopes, independent. Same slopes, different y-intercepts, inconsistent. And same everything is dependent. So that's a pretty easy thing. One thing I do need you to do on your homework, I need you to not do question 15. We're skipping 15 and going, the assignment's exactly the same, but change 15 to 17 to whatever odd. Okay, it's just one question I'm taking out. If you do the extra question, it's not going to kill you, but I chose to put that information on hold for now. So that's it. Just take out number 15 and just do 17.